Hey everyone, today we'll be going over titration curves. This time around we'll be going over the titration of weak acids by strong bases. So let's get this started. Okay, so consider the titration of 50 milliliters of 0.1 molar acetic acid with 0.1 molar sodium hydroxide. Calculate the pH when no sodium hydroxide has been added. Well, because no sodium hydroxide has been added, we can just treat this as a normal weak acid problem. So let's write our reaction first. We have our acetic acid ionizing into H plus and acetate ion. Now let's make our ice table. So it says initial. So the initial is going to be 0.1, and these are going to be 0, and it's going to change by some factor which we're trying to find. And here are the equilibrium concentrations. We have our Ka value, so we're good to go. Ka is equal to 1.8 times 10 to the negative fifth, which is equal to x squared over 0.1 minus x. And because x is going to be really small, we can ignore this minus x right here, making this problem a lot easier to solve. And if you solve it, you should get that x is equal to 0.001342. And now we just plug that into the pH equation, and you should get that the pH is 2.87. So before the base is added, we just treat this like a normal weak acid problem. Unfortunately, things only get harder from here on out. Okay, so this time around we want to find the pH after 10 milliliters of 0.1 molar sodium hydroxide has been added. And this is hard because we have to take into account two things. We have to address the hydroxide ions, and we have to address the change in volume. So before we even do anything, the first thing we should do is just find how many moles of stuff that we have. So first of all, let's find how many moles of acetic acid we have. So that's just going to be 50 times 0.1. So that's going to be 5 millimoles of acetic acid. And let's find how many moles of hydroxide ions we have. That's going to be 10 times 0.1. So we have 1 millimole of hydroxide ions. And in a previous video, I stated that hydroxide ions will react with weak acids to form more conjugate and some water. So in this case, the hydroxide is going to react with the acetic acid to form acetate ion and water. Okay, so now we have our initial, and here's our final. So initially we start off with what? 5 millimoles of acetic acid. So I'll put 5 here, and we start with 1 millimole of hydroxide ions. And 0, 0. Okay, well that doesn't really matter. Okay, so now after the reaction, this is going to go down to 0, this is going to go to 4, and this is going to go to 1. And this doesn't matter. So now we know how many millimoles of acetic acid and acetate ion we have. Okay, we know how many millimoles we have, but we don't know the concentrations yet. So that's a whole nother ordeal we have to do. That's a whole nother thing we have to do. So I'm just going to erase everything. Okay, so now things get real. Okay, now things get really tricky. Okay, so now that we know how many millimoles of acetic acid we have and how many millimoles of acetate ion we have, we can finally we're now much closer to finding the pH. So now we have to set up another ice table. This time we're just going to do the normal acetic acid ionizing. So we're going to have this ionize into H plus and acetate ion. And now we have initial, change, and equilibrium. Well, this time it's going to be okay. So the initial concentration is going to be 4 millimoles. 4 millimoles divided by 60 milliliters. See, a lot of people forget this 60, but it's really important because this is just the how many millimoles we have, but this is not the same thing as concentration. So you can always remember to divide the number of moles by the volume, okay? So this is going to be 0, and this is going to be 1 over 60. And where do I get 60 from? I got 60 by adding 50 and 10 together. Okay, so this is going to decrease, this is going to increase, and it's going to increase. It's going to go to the right because there's 0 H plus ions. And now we have our equilibrium. Okay, so 460 minus x plus x and 1/60th plus x. And now let me erase the bottom really quick. Yeah, these problems take up a lot of space, unfortunately. Okay, so now we know what our Ka is, so now we're finally good to go. So Ka is equal to 1.8 times 10 to the negative fifth, and that's equal to all this stuff. So products over the reactants. Okay, we're almost done. We can cross out the x's because we know x is probably going to be really small. And now we just solve this equation. And you should get that x is around 7.2 times 10 to the negative fifth. And if you plug that in to the pH equation, you should get that the pH is around 4.14. So yeah, that's a really tough problem. There's just so much stuff you have to remember. You have to remember how hydroxide ions react with weak acids to form more conjugate base, and you have to take into account the change in volume. Okay, now we have reached the hardest part of the problem. Now we want to find the pH after 50 milliliters of 0.1 molar, forgot to write the M there, sodium hydroxide has been added. Well, that's actually, so if you notice, there's going to be 5 millimoles of acetic acid, and there's going to be 5 millimoles of sodium hydroxide. And what does that mean? Well, that means we have reached the equivalence point. Enough base has been added to neutralize all of the acid. So as we went over in the previous problem, that OH reacts with acetic acid to form acetate and agua. And now let's do our initial and our final again. So these are both going to be 5 millimoles. This is going to be 0. This doesn't matter. and now they're going to react to completion. Now we have 0 millimoles of hydroxide ion, 0 millimoles of acetic acid, and 5 millimoles of acetate. Okay, so we got that down now. Okay, now I'm going to make some room here. So I'm just going to erase this. Yeah, I'm gonna erase that too. I'm just gonna put OH right here, just so we know what we're talking about. Down here, H2, oh shoot, HC2, H3O2, and C2H3O2 minus. Okay, so yeah, I'm just gonna make some room here. Okay. So what happens from here? Well, now we have to worry about the reverse reaction. The acetate is going to react with the water to form acetic acid and hydroxide Okay, I know that's, a little weird, but just go with it. Just remember, yeah, this is just a reverse action of what we just went over. So, yeah, let's do this. So let's make an ice table. Ice table. Okay, so what are our initial concentrations? Well, the acetate ion, we have 5 millimoles, but we had to divide by 100 milliliters because that is now how big our solution is. And, the H2O doesn't matter, and these are going to be 0, obviously. And now it's going to, it's going to decrease here, it's going to increase over here. And, yeah, so here is our equilibrium concentrations. Now I can erase this. Okay. But there's, okay, so now, just a second. So we have Ka, so we're good to go, right? Not necessarily, because this is, because it's a reverse action, we have to use Kb instead of Ka, because we reversed it. So, first, before we can do anything, like we usually would, we have to find Kb first. But fortunately, that's really easy, because Kb is just equal to Kw over Ka, and what is that? 10 to the 14th, over 1.8 to negative 15th, that's going to be 5.6 e to the negative 10. Okay, so now we have that. So that's what Kb, our Kb is. So now we have to set that equal to x squared over 0.05 minus x, and once you solve that, you can pretend that this minus x right here is going to be really small. So you can just take that out, and you will get that x equals 5.3 e to the negative 6th. Okay? So that is the hydroxide ion concentration right here. So we're not done we're not done quite yet. We have our this is, I'm just gonna write down here so you remember for reference, OH minus concentration now. But we want to find the pH, right? So yeah, we have to plug this number into the pOH formula, and then subtract that number from 14. So here's what I mean. So pOH is equal to negative log of 5.3 e to negative 6, and that should get us, just give me a second. A negative log of 10 times 5.3 to negative 6. Okay, and that should get us a pOH of 5.27. Oh, yeah, 5.27. And now to find the pH, we subtract this number from 14, and we should get around 8.73. So yeah, that is the pH at the equivalence point. And as you notice, because we're dealing with a weak acid with a strong base, it's going to be the solution is going to be basic at the equivalence point because this strong base wins over the weak acid. So yeah, this is as hard as it gets, but there's one more type problem we need to familiarize ourselves with. Okay, and now we're finally here. Our last problem. Now we want to find the pH when 60 milliliters of 0.1 molar sodium hydroxide has been added. And now, yeah, this problem. Okay, well, let's think about it. Okay, so this time around, now there's going to be more base than acid. So let's go back to the reaction we've been going over and over again. OH plus acetic acid makes acetate and agua. Okay, so here we go. Okay, so how do we do this? Okay, so now we have 0.6 millimoles of hydroxide ion, and we have 5 millimoles of acetic acid, and this is going to be 0. And this is going to be 0. Ooh, shoot, why did I put H plus? I meant H2O. And this stuff doesn't matter. Okay. So this is going to end up being 1, this is going to be 0, and this is going to end up being 5. Okay. So now we know that we have 1 millimole of hydroxide, 0 millimoles of acetic acid, and 5 millimoles of acetate. Well, things actually get a little easier here because we know that acetate is a weak base compared to OH minus. So the amount of OH minus produced by the reaction of acetate with water will be very small compared to the excess OH minus. So we can just really ignore this 5 right here. Okay, so now, yeah, just ignore this, just ignore the amount of acetate because it's only a weak base, and whatever hydroxide ions the weak base produces, it's going to be overshadowed by the excess hydroxide ions already present. So yeah, now to find the pH, we simply find the hydroxide concentration first. So the oh shoot, I changed my color. Okay, the hydroxide concentration is equal to 1 millimole. But now how many? So how many? Well, how big is our solution now? It's gonna be 110. It's gonna be 110 milliliters now. So that's gonna equal 9.1 times 10 to the negative third. And now we find the pOH, which is going to be negative log of that, 9.1 e to negative 3. That's going to be, let's see, that's going to be 2.04. And now I can finally find the pH. And we are done. You should get 11.96 as your final answer. And we are done, guys. Yeah, so after the equivalence point, you can just ignore this part right here of what's going on with the conjugate or the acetate, whatever, and just focus on the OH minus and on the hydroxide. And yeah, that's a wrap. Yeah, so if you could solve these types of problems, you're good. And I hope you enjoyed the video. I hope I wasn't that bad. And see you later.